Hello and welcome to Grade 3 Math Dive in 5. My name is Daryl Frost,
I'm Barbara Knox.
and today we're focusing on problem solving using the 4 operations. So in just a moment, you're going to pause the video and you're going to complete a task on the next slide on your own or with a team or partner. Solve the problem using any strategy and write an equation that represents the problem. As you are working through the task, reflect on the 3 questions that you see on the slide.
See you back in a few minutes.
So here is the progressions with BEST. We're going to focus on third grade AR1-2 solving, it says 1 and 2 steps, but the task that you engaged in is on a two-step problem. So you can just take a look at all of these here and see how they all connect, but we're focusing on a third grade AR1-2. So within this current scope, the vocabulary or academic language you see there is what should be front and center on your boards as you focus and facilitate the explorers within this scope or unit. The language should be used by both you and the students. Notice here that within this scope, students will be using a variety of strategies.
They're going to get those strategies from the anchor charts you've been developing all year. So we're not just focusing on multiplication and division in this unit. You're going to have to make sure that your addition and subtraction anchor charts are also available to them because they'll be doing multi-step problems that will involve all 4 operations.
And so they'll be able to use those anchor charts to reference their thinking. Okay, so welcome back. So let's take a look and you can compare your strategies to what we have here on our slide with this. As we know, it's a 2-step problem. So Barbara, take a look at this here. What do you notice about what you just see or what I just flashed?
I see a bar model, so that's one way to represent. I see the problem broken down into the 2 factors and the missing product, and everything is labeled very well. Not all problems have a specific first step, but with this problem, Daryl, if I hadn't solved this part of the problem first, I wouldn't be able to figure out the total number of reading minutes.
I had to know how many minutes Ramon spent on math. So it's kind of like I knew the total.
Right.
So I had to begin with thinking about that first, right?
Yes, I did.
So that was a definite step 1. But to your point, no, they don't always have to be. What do you see here?
Here I see a part whole model, right, which is another type of bar model. So I've broken down, if I know that the math minutes are 32, that missing part has to be my reading minutes.
And notice it's labeled, this is the reading homework.
Right.
So, and I've labeled step 1, step 2. Do I have to subtract here?
No, I could have thought about it with counting up to subtract, right? So I might have done a missing add-in. 32 plus something is going to give me my 79 total minutes.
And another strategy that builds procedural reliability, I could have thought about this on a number line.
You could have.
Because I just thought about that. I saw it when you said think addition to subtract.
Right.
Yeah. So here are some potential misconceptions that you may run into or encounter as you teach this particular unit. I want to highlight the third one there, the benefit of estimation. Going back to the homework problem with Ramon, students, if you had them estimate first and to think about, okay, well, I know the answer has to be less than 79 minutes because Ramon didn't, that was his total amount of time.
So if I get an answer that's more than 79 minutes, I should know that that's not the right answer.
And that's
what I hear you saying.
That's exactly right. It also helps them think about the actions of what's happening and just not taking 2 numbers and doing something. I know how to add, so I'll add them.
I also want to focus on that last bullet on this slide. This is very common that students will only complete 1 step when it's a multi-step problem. Now, if we think back to our homework problem, students might have figured out how much time they spent on math, and that was their answer. 32 minutes is my answer, and they think they're done when they haven't found the number of reading minutes.
So let me ask you this, Barbara, you do a lot of test writing on a multiple choice. Let's say you wrote that problem. On a multiple choice assessment, would you have had 32 as an
32 would have been an answer.
Yes, because that shows
Because
that
that's a common misconception that we want to check for.
Excellent. Well, we hope today's Math Dive in 5 on problem solving with the 4 operations has been helpful to you and given you some insight on facilitation of this scope.
We'll see you back next time.
Bye.
Bye.